The FLSUN S1 Pro is a faster 3D printer compared to the Bambu Lab X1C. But is it a better value? That's what we're going to find out in this video. Hi, I'm Ken of Rist Innovations and welcome to today's video to compare everything about the FLSUN S1 Pro and the Bambu Lab X1C 3D printers, so you can make an informed decision on which one to buy if you are considering these printers. I've organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. First, I jump right into comparing the print quality of both printers because I think that's the most important thing to consider when making a buying decision. Next, I'll cover the key features of each printer and point out what they have in common as well as their differences. Then, I'll compare the unboxing and setup of both printers, followed by comparing the cost of both printers. Lastly, I'll provide my final summary and recommendations. I just want to mention that I bought the Bambu Lab X1C with my own money. However, I want to thank FLSUN for sending me the S1 Pro for my evaluation. Okay, let's get started. So comparing the parts quality and speed. I printed parts on both the S1 Pro and the X1C using PLA, PETG, the new TPU for AMS, ABS glass filled, and even nylon carbon filled. And I think you're going to be surprised at the results. First, let's cover PLA. I know this isn't a big challenge, but first I printed a Benchy designed by Creative Tools in PLA on both printers. The X1C Benchy took 39 minutes to print, which I know is a long time, but it turned out great as expected. The first S1 Pro Benchy from FLSUN's preloaded files was made in only 8 minutes using FLSUN's high-speed PLA. It wasn't the best Benchy I've ever seen, but I was pleasantly surprised at the quality for an 8-minute Benchy. There were some defects in the hull and some sagging in the front window, and the anchor holes weren't round, but this wasn't bad for such a fast print. To compare apples to apples, I loaded the Benchy file I had used for the X1C printer. This second print took 17 minutes versus 39 minutes for the X1C. But the quality of the S1 Pro was excellent. I was most impressed with how clean the spans were over the doors and window. There were a few stringers, but other than that, this thing was beautiful. If you have a 3D printing need, but you don't have a 3D printer, I have the solution for you. That brings me to the sponsor of today's video, PCBWay. If you are working on any prototype projects, they can help you when you need a variety of parts. They have a large amount of resources to provide you with all your PCB needs. Besides making PCBs, they also offer CNC machining, sheet metal fabrication, injection molding, and lots of different types of 3D printing, including metal printing. You just need to go on their website, upload your design, select the material and quantity, and you'll get an instant quote. Next, their engineering team will review and approve the quote, and as soon as PCBWay receives payment, they will manufacture your parts and ship them right to your door. Give them a try. I think you'll be amazed at what they can do for you. I have a link in the description below. Now, back to the show. I also printed this calibration test designed by Gabox 3D on printables using Bambu Lab PLA for the X1C and FLSUN high-speed PLA for the S1 Pro. The X1C took 1 hour and 44 minutes to print, while the S1 Pro took 51.5 minutes to print. For the X1C, the overhang test results indicate that there was a slight issue at 60 degrees, but it did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.82 millimeters, 7.78 millimeters, 5.79 millimeters, and 3.91 millimeters, versus design diameters of 10, 8, 6, and 4 millimeters respectively. The various rectangular lengths measured 10.04 millimeters, 19.99 millimeters, and 29.94 millimeters. For design lengths of 10, 20, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the part. For the S1 Pro, the overhang test results were excellent. It did successfully print all the way to 80 degrees. Various cylinder diameters measured 9.72 millimeters, 7.63 millimeters, 5.57 millimeters, and 3.66 millimeters. Diameters of 10, 8, 6, and 4 millimeters respectively. The various rectangles measured 9.92 millimeters, 20 millimeters, and 29.95 millimeters for design lengths of 10, 20, and 30 millimeters respectively. Bridging overall looked good, and there was little to no stringers on the S1 Pro part. However, the skinny square columns were partially deformed. Overall, I consider both calibration parts to be essentially the same quality and accuracy. I also printed this spiral vase designed by Max413049 on printables using the Bambu Lab PLA Basic. The X1C took 5 hours 50 minutes to print, while the S1 Pro took 4 hours and 56 minutes to print. Both parts turned out excellent with no difference between the quality of the parts. To demonstrate the advantages of the S1 Pro using high-speed PLA, I printed this Prusa rocket engine in 4 hours and 27 minutes, and it turned out beautifully. I did have 2 failed prints without using supports, so this last one I printed with supports. This print would have taken me 9 hours to print on the X1C. Now, PETG. Next, I printed an iPhone charger designed by Print and Paddle 2437095 on printables using Bambu Lab PETG. The X1C took 3 hours 37 minutes to print, while the S1 Pro took 2 hours and 10 minutes to print. The X1C part turned out fairly nice overall. There were some rough areas where the tree supports were attached. Also, there is a defect near the bottom of the print, and there is some ghosting on other areas. The S1 Pro also turned out fairly nice overall. Just like with the X1C, there were some rough areas where the tree supports were attached, but I didn't see the ghosting on the S1 Pro part. Overall, I would give a very slight edge to the S1 Pro part. This TPU is a new material from Bambu Lab that is compatible with their AMS, or their automated material system that feeds filament into the printer. Previous TPU had to be loaded manually because it wouldn't work with the AMS. This new filament is stiffer than the normal TPU, so let's see how it prints. The X1C took 2 hours and 28 minutes to print, while the S1 Pro took 4 hours and 47 minutes to print. The reason why the S1 Pro took so long is that it only has a standard TPU slicer setting, so nothing specific to this Bambu Lab Special TPU. For the X1C, I printed 10 pieces of these tracks for a death racer I'll be building shortly. The Death Racer project is a joint effort between Michael Baddeley and Sam Prentice of the Real Sam Prentice YouTube channel. Links are in the description. I was pleasantly surprised that there was little to no stringing with the new TPU material. The quality of the parts from the X1C turned out great. However, they are a bit stiffer than the standard TPU material. For the S1 Pro, the parts also turned out quite good. Again, there was little to no stringing, other than between 2 pieces, but otherwise they were comparable to the X1C parts. One part was damaged at the top because it became dislodged from the build plate. I give a slight edge to the X1C parts. Okay, now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. I decided to print this pipe wrench designed by 3dprintedhardware.com. The X1C took 2 hours 25 minutes to print, while the S1 Pro took 1 hour and 29 minutes to print. For the X1C, the wrench turned out excellent. The main body, hook jaw, and nut all printed without any warping. For the S1 Pro, the wrench almost had the identical results with no warping of any of the parts from the bed, and everything fit together perfectly. There were some cosmetic defects on 2 areas of the top surface, and at least on one of the areas it was due to the tree supports not staying secured, so it caused that area to slightly curl up. I give the slight edge to the X1C part. Okay, now let's get wild and crazy and print with ABS glass-filled filament. I decided to print the Death Racer's drivetrain parts, including a set of track wheels, motor frame, and a motor mount. I did use a brim to give me the best chances of success. The X1C took 5 hours and 35 minutes to print, while the S1 Pro took 3 hours and 43 minutes to print. For the X1C, the parts turned out excellent with no warping. Also, the mating track wheels fit together perfectly. For the S1 Pro, The motor frame had some slight warping and the large holes had a rough surface. Also, the mating track wheels did not fit together due to an interference fit. For the ABS glass-filled parts, the X1C were of a higher quality. Now, do you want to get totally nuts? How about printing a nylon carbon-filled part? I used Bambu Lab's PA6 nylon and carbon fiber filament. I printed the same pipe wrench designed by 3D printed hardware.com. First on the X1C, then on the S1 Pro. The X1C took 2 hours 44 minutes to print, while the S1 Pro took 2 hours and 17 minutes to print. For the X1C part, the wrench printed excellently with no warping. Now let's see how the S1 Pro was able to print with the carbon-filled PA6 nylon pipe wrench. It also turned out great, with no warping, so both wrenches from the S1 Pro and the X1C were identical with their quality. So, for my last quality test, let's use some glass-filled ABS and let's slow down the S1 Pro to the identical settings of the X1C to see if at identical parameters if the quality is also identical between the two printers. The old time to make these parts on the S1 Pro was 3 hours 43 minutes, and with the new parameter settings similar to the X1C, the new time to make these parts on the S1 Pro is 5 hours and 3 minutes, which is similar to the 5 hours and 35 minutes for the X1C. I was surprised that slowing down the S1 Pro print speed to 5 hours didn't improve the quality as much as I had expected. In fact, I would say overall, the ABS glass-filled parts printed on the S1 Pro looked basically the same, whether I printed them at the approximately 4 hours versus the 5.5 hours. In both cases, there was some slight warping and the large holes had a rough texture to them. Also, the mating track wheels did not fit together in either case. I will have to spend some more time investigating this. Based on my initial tests, identical parts printed a range of between 15 to 58% faster on the S1 Pro versus the X1C, depending on the filament material. However, at a cost of slightly lower quality results, depending on the filament material. For PLA, PETG, TPU, ABS, and carbon-filled nylon, the quality between the two printers was essentially the same. Very good to excellent results. However, for ABS glass-filled parts, the faster time for the S1 Pro resulted in lower quality parts. Slowing down the print time on the S1 Pro to that of the X1C for glass-filled ABS didn't improve the quality. On the other hand, for high-speed PLA, the S1 Pro really shines because it takes advantage of the high-speed capabilities of the printer. It can print high-quality parts at a much faster speed than the X1C. Now let's compare the main features of the S1 Pro and the X1C. The S1 Pro has a larger overall printer dimensions of 550 millimeters by 595 millimeters by 1030 millimeters versus the X1C dimensions of 389 millimeters by 389 millimeters by 458 millimeters. The S1 Pro weighs 41 kilograms or 90 pounds versus the X1C weighs 14 kilograms or 31 pounds. The S1 Pro is heavy enough that you should consider getting some help to unbox it or to move it around. It does have some nice handles on the side that make it a bit easier to pick up. The S1 Pro has a larger print volume in the shape of a cylinder of 320 millimeters diameter by 392 millimeters high if you don't count the dome area on top, which equals 31.6 cubic centimeters, versus the X1C print volume in the shape of a cube of 256 millimeters by 256 millimeters by 256 millimeters, which equals 16.8 cubic centimeters, so approximately half the volume of the S1 Pro. They are both fully enclosed. However, the X1C is a Core XY printer and the S1 Pro is a Delta printer. They both have a rigid internal frame and metal and glass panels and doors. The S1 Pro has a maximum hot-end temperature of 350 degrees C, while the X1C has a maximum hot-end temperature of 300 degrees C, so 50 degrees lower. The S1 Pro and the X1C have a maximum build plate temperature of 120 degrees C. The S1 Pro has a maximum speed of 1200 millimeters per second versus the X1C has a maximum speed of 500 millimeters per second. The S1 Pro has a maximum acceleration of 40,000 millimeters per second squared. However, the X1C has a maximum acceleration of 20,000 millimeters per second squared. They both have a filament runout sensor and a chamber fan with a carbon filter, but the S1 Pro also has a HEPA filter. The X1C has a nozzle wipe feature, however the S1 Pro does not have this feature. The X1C has a multicolor filament multi-material capability when using the Bambu Lab AMS, or their Automated Material System unit. And they can take advantage of the Bambu Lab RFID tags in the bamboo filament spools that allow the AMS to recognize the color and amount of specific materials on each spool. The S1 Pro does not have a multi-filament, multi-material capability. And for the S1 Pro, you need to manually cut the filament before changing filaments. The X1C has an auxiliary parts cooling fan. However, the S1 Pro has a blower on top and a CPAP type of hose that delivers airflow to the parts below. Both printers have a textured PEI build plate. However, the S1 Pro only has the texture on one side of the build plate. The X1C works with the Bambu Studio Slicer and the phone app, the Handy, while the S1 Pro works with the FLSUN Slicer and their phone app. Both printers print wirelessly using the slicers or phone apps. They both have auto bed leveling, Z-axis offset, power loss recovery, internal LED light. You can set the X1C in land mode. However, there have been some recent blog posts from Bambu Lab describing a new firmware update that introduces some restrictions that has concerned many within the 3D printing community. I published a separate video on that topic, which is in the description below. It's my understanding that for the S1 Pro, you don't have these same restrictions. The S1 Pro uses Clipper. You can print the following filaments on both printers: PLA, PETG, TPU, ABS, ASA, nylon, and carbon or glass-filled polymers. The X1C offers several nozzle sizes, including 0.2, 0.4, 0.6, and 0.8 millimeters. However, as of now, the S1 Pro only offers the 0.4 millimeter diameter. Regarding replacing hot ends, it's more complicated to replace the hot end on the S1 Pro versus the X1C. I have a link to the S1 Pro hot end replacement video from FLSUN in the description below. Both printers come with a hardened steel extruder and a 0.4 millimeter diameter nozzle. The S1 Pro has a 7-inch color LCD touchscreen, while the X1C has a 5-inch color LCD touchscreen to communicate with the printer. They both have high-resolution 1080p cameras. For file storage, the S1 Pro has a 16GB eMMC and a 32GB USB flash drive, while the X1C has a 4GB of internal memory plus the removable microSD card. The X1C has LiDAR, which operates a filament flow calibration, the first layer inspection, and spaghetti detection. The S1 Pro has a flow calibration, spaghetti detection, debris detection, and pressure advanced functions. However, the spaghetti detection and debris detection are in an experimental mode. The S1 Pro has a unique feature, which is an actively heated dry box for the filament. You can choose one of the following temperature ranges: 45 to 50 degrees C, 50 to 55 degrees C, or 55 to 60 degrees C. And you can set the time up to 24 hours. The X1C does have a dry box mode. However, unlike the S1 Pro, you need to turn your X1C into a dry box for the time you are drying your filament, so you can't print parts at the same time. Both printers have similar unboxing instructions. If you're interested in my detailed unboxing and setup of my X1C, I have a link for that video in the description below. For the S1 Pro, it's nearly completely assembled right out of the box. You only need to add 2 glass doors and the LCD panel, and you're ready to go. For the S1 Pro, as I mentioned earlier, it is a heavy printer, weighing 41 kilograms or like 90 pounds. So you should get some help lifting this printer out of the box, and also when you're moving it around. After removing the printer from the box, remove the box that contains the glass doors. Next, a small accessory box has a cutter, a glue stick, USB drive, spare hot end, grease, nozzle cleanout tool, some Allen wrenches, and the door hinge screws. First, install the filament glass door and door handle. Next, install the main glass door and door handle. Then, remove the 3 clips that are securing the 3 axis belts. Next, install the LCD screen by connecting the cables to the back of the screen, securing the screen to the printer. Then, attach the power cord, plug it into an electrical outlet, and turn the printer on. Follow the screen prompt by choosing your preferred language, then connect to your Wi-Fi. Then, perform motor calibration, vibration compensation, and bed leveling. Install filament into the printer and follow the load prompts on your LCD screen. Set the nozzle temperature. Choose your first print from the menu and begin printing. At the making of this video, February 2025, Bambu Lab is currently having a sale on their X1C printer for $1,149, normally $1,199. This is without their AMS system. FLSUN is currently having a sale on their S1 Pro printer for $1,399, normally $1,499, so a price difference of $250 more versus the X1C. So now it's time to go to my final summary and recommendations. So is the additional $250 cost for the S1 Pro worth the different features of the two printers? Here's a brief summary of the features that are different between the two printers. I'm very impressed with the speed of the prints I made on the FLSUN S1 Pro, including prints made from PLA, TPU, PETG, ABS, including glass-filled, and carbon-filled nylon. The S1 Pro prints between 15 to 58% faster than the X1C, depending on the material. However, with speed comes some cost in quality, because comparing the overall print quality of the FLSUN S1 Pro to the Bambu Lab X1C, I give a slight edge to the X1C. With that said, the S1 Pro really excels with high-speed PLA because it made the same high-quality parts as the X1C in half the time. I plan to do more experiments with slightly slowing down the S1 Pro using various materials to see what, if any, impact that has to the print quality. The S1 Pro has almost twice the print volume of the X1C, so if you print a lot of large parts, then the S1 Pro has the edge. The S1 Pro has a maximum hot end temperature of 350 degrees C versus the X1C maximum temperature of 300 degrees C. So if you're focused on higher temperature engineering materials, then the S1 Pro has the edge. The X1C has the multicolor, multi-material capability if the AMS is purchased. The S1 Pro doesn't have this capability. So if you need multicolor printing capability, the X1C definitely has the edge because they have a proven technology in their AMS unit. The X1C has LiDAR, which provides a filament flow calibration, first layer inspection, and spaghetti detection. The S1 Pro also has spaghetti detection, flow calibration, and pressure advance features. However, the spaghetti detection and debris detection are in an experimental mode, so they need more refining. The S1 Pro has an actively heated dry box with a choice of temperature range from 45 degrees to 60 degrees C up to 24 hours. For the S1 Pro, I did have several print failures due to the prints not sticking to the build plate. FLSUN recommends using a glue stick, but I'm not a big fan of glue sticks, so I applied a coating of the Vision Minor nanopolymer adhesive, and that really improved things. Overall, FLSUN made several improvements to their S1 to create their S1 Pro, and I think the S1 Pro offers several advantages over the X1C, including 2 times the print volume, twice the speed, and similar print quality, depending on the material. The S1 Pro is a very large and heavy printer. It's more complicated to change the hot end, and as of the middle of February 2025, FLSUN only offers the 0.4mm diameter nozzles. But overall, I think the S1 Pro is a worthwhile consideration. Of course, Bambu Lab set the standard of overall 3D printing experience when they launched the X1C. So if you prefer taking the safer route based on the many satisfied customers that have been using the Bambu Lab X1C, then the X1C may be the better choice for you. This just in. FLSUN has just provided me an affiliate $100 discount code for anyone who purchases an FLSUN S1 Pro between now and the end of February 2025. This is in addition to their current sale. This means the total cost of the printer will be $1,299. If you'd like to take advantage of this, then just click on the affiliate link in the description below, and in the coupon section, type in FLSUN RISTINNOV. The additional $100 savings will be for FLSUN's US store only. I recommend that you watch other reviews of the FLSUN S1 Pro so that you can make an informed decision as to whether the S1 Pro is the best choice for you. Good luck with your decision. And now, back to your regularly scheduled program. What do you think? Which of these printers would you buy? Let me know in the comments below. If you'd like to see my most popular video titled The 10 Best Upgrades to Your Bambu Lab Printer, which has over 390,000 views, that link is here. If you'd like to see my recent video titled Qidi Plus 4 3D Printer, Better Value Than the X1C, that link is here. Thanks for watching. Bye!